Beneath this calm water, China buried one of its boldest transport machines.
On one side stood Shenzhen. On the other, Zhongshan waited across the water. Before this link, the journey often meant a long detour around the estuary. Engineers drew a straighter line, then discovered the sea would fight every meter. Massive ships still needed room, even as a highway crossed their path.
Where a bridge could not rise, the road had to dive beneath the sea.
This tunnel was not drilled. It was built in pieces, then sunk.
Each section was a floating building, designed to become part of the seabed.
Inside each tube was not emptiness, but a future 8-lane highway. Steel and concrete became armor against pressure, salt water, and time.
Underwater, every surface must survive a force travelers will never feel.
Before the tunnel could sink, the seabed had to be carved with precision. The ground below was not solid rock. It was a moving archive of sediment.
Engineers had to map what waves, mud, and darkness tried to hide.
Here, the tide was not scenery. It was the construction schedule.
When sealed, the giant tube floated like a ship without a destination.
Moving it across the estuary required power, patience, and almost no mistakes.
At sea, the construction site had no walls, only coordinates.
To sink the tube, engineers first had to control its desire to float.
Below the surface, the largest movements became almost invisible. There was a subtle deep underwater industrial hum in the background. A structure this heavy still had to land with near-surgical accuracy.
The joint mattered as much as the tube itself.
Only after sealing could workers turn a sunken shell into a dry passage.
One success was not enough. The process had to work again and again.
The final gap was small, but the pressure behind it was enormous.
When the final joint locked in, the hidden highway became continuous.
The islands were not decorations. They were machines disguised as land.
To make the tunnel usable, engineers first had to manufacture shoreline. Here, daylight ends, and the sea quietly passes overhead. Drivers enter a tunnel, but they are really crossing beneath an estuary.
The tunnel's greatest trick is making extraordinary engineering feel ordinary.
A road beneath the sea still needs to breathe.
Every hidden corridor exists for a moment. Engineers' hope never arrives.
Once opened, the mega project became a living system, watched in real time.
After the tunnel, the road climbs back into wind and light.
Above the water, the visible monument begins.
The bridge survives by turning weight into tension. Across open water, wind becomes an invisible load. A sea crossing must be designed for days when the sea turns hostile.
Salt water does not attack suddenly. It waits.
Opening day is not the end. It is the beginning of maintenance.
For 7 years, the estuary became a moving factory. Before steel moved, thousands of decisions had already shaped the crossing.
The seabed had to be questioned before it could be trusted. Every tower above the sea begins with unseen strength below it.
Slowly, the project rose out of the water. Strand by strand, the bridge learned how to carry weight.
The future road arrived in pieces, suspended above the estuary.
Concrete and steel became a road only when the surface was ready.
Before drivers arrived, the crossing had to prove itself.
On June 30, 2024, the hidden machine opened to the public. A trip once measured in hours could now be measured in minutes. This shortcut was built for people, freight, airports, ports, and cities. In modern cities, distance is not only geography, it is cost. For commuters, a mega project becomes personal when it saves a morning. Near Shenzhen's airport, height was not just engineering, it was airspace.
A taller bridge can solve shipping, but create problems in the sky.
The genius was not one structure. It was the combination.
Bridge, island, and tunnel became one continuous machine.
The most difficult kilometers were the ones nobody would see.
A tunnel is not a hole. It is a layered life support system.
The sea stays outside because countless smaller systems keep working.
In an immersed tunnel, the weakest place can be the connection.
Every seal had to earn trust before traffic ever arrived. The safest disaster is the one engineering prevents from growing.
Air underground must be guided, measured, and controlled.
Inside the tunnel, traffic flow becomes part of the engineering.
8 lanes run beneath water that once divided 2 urban worlds.
The road was designed for speed, but governed by control.
At night, the undersea road feels almost weightless.
Above, the bridge glows. Below, the tunnel disappears.
The waterway could not simply stop while engineers worked.
A crossing that blocks ships would fail before it opened.
Where ships needed sky, the bridge rose.
Where height created conflict, the tunnel took over.
The design worked because it accepted contradictions instead of ignoring them.
Even the island's shape was part of the engineering.
Artificial land survives only if its edges can answer the sea.
In an estuary, the ground and water are always negotiating. If currents steal the seabed, foundations lose their support. Even after completion, the seabed remains part of the project.
A mega project this large must listen to itself.
Tiny changes can reveal how a giant structure is aging.
The best repair is often the one made before anyone notices.
Behind every impossible machine are people making careful choices.
At sea, routine is what keeps ambition safe.
Sometimes the most important construction decision is to wait.
When the water calmed, the clock started again. For hours, one enormous section moved slower than a walking person. Success was not dramatic. It was confirmed by numbers.
A place that had been underwater became a room humans could enter. The tunnel was built twice, first as structure, then as roadway.
Safety often appears as lines, lights, and small decisions. Now the impossible feels like an ordinary drive. The sea crossing returns to daylight without announcing what happened below. The bridge is what travelers remember. The tunnel is what made it possible. Infrastructure changes maps, but it also changes how cities imagine each other.
In this region, roads are economic circuits. The crossing was built where sea commerce and road commerce collide.
This was never empty water. It was a living estuary.
Every marine project leaves questions engineers must manage carefully.
Dredging solves one problem while creating another to control.
In modern construction, water quality becomes part of the blueprint.
Mega projects do not erase trade-offs. They manage them.
The verified price was enormous, even without myths around the number. Money here bought precision, materials, time, safety, and risk reduction.
From above, risk looked like calm water. Tide, wind, sediment, and traffic shaped every decision.
The tide could turn a perfect plan into a missed window. Wind turns height and distance into engineering problems.
Sediment can bury, shift, and undermine what engineers place. The project had to serve traffic while surviving traffic. Every layer solved a problem the others could not.
Beneath the surface, the road network becomes more complex than it appears.
For drivers, complexity must disappear into clarity.
A safe tunnel must also feel safe.
Light turns an underwater passage into a readable space.
Safety depends on exits most travelers never use.
Beside the public road, a hidden service world keeps everything alive.
Underwater infrastructure depends on electricity behaving perfectly. Engineers design backups because certainty is never guaranteed.
A crossing this long must be watched meter by meter.
The goal is not drama. The goal is order. Preparedness is practiced long before it is needed. Every traveler places trust in engineering they cannot see.
A mega project is never one genius. It is thousands of disciplined tasks. Immersed tunnels are rare, but they belong to a global engineering tradition.
Here, the distinction was scale, width, and integration.
Records attract attention, but function is what justifies the scale.
What looks impossible from a distance becomes method up close.
First, engineers had to understand the sea.
Then they built pieces too large to understand from ground level.
They floated the giant because moving it on land was impossible.
They sank it carefully, turning weight into placement. They sealed each joint until separate pieces became one road. Then they protected it from currents, anchors, pressure, and time. Finally, the hidden tunnel had to connect to the visible world. The final miracle was that it became routine. When travel changes, the map in people's minds changes too. Infrastructure does not guarantee growth, but it changes where growth can happen. Calling it impossible is dramatic. Understanding it is better. The achievement was making many difficult systems behave like one.
The most important part of the crossing is hidden from every driver.
Great engineering does not defeat nature. It negotiates with it. Future crossings may look less like bridges and more like systems.
And here, across Lingdingyang, that future is already carrying traffic.
Ordinary vehicles now travel a path that once demanded extraordinary imagination.
The sea looks unchanged, but beneath it, the map has moved.
The hardest part of progress is often the part hidden below the surface.